Welcome back to looking at algebra. Let's jump into Anki. What do we got? Boom, 8 flashcards. What does it mean to say that matrices A and B are row equivalent? You can obtain one from the other with only using elementary row operations. State 3 results that are equivalent to the statement that A is invertible. The AX equals 0, there's only the trivial solution. The reduced rational form of A is I, identity matrix, and A can be expressed as a product of elementary matrices. Hey, hey, Alright, there we go. Good. If A is an invertible matrix, how is the transpose of its inverse related to the inverse of the transpose? They're equal, right? The inverse of the transpose is equal to the transpose of the inverse. The inverse of the transpose is transpose, yeah. If the matrix B results from the matrix A by performing one elementary row operation, how might you recover A from B by performing one more elementary operation? You basically do the opposite, but if you multiply a row through by a non-zero constant, you're going to multiply through by that constant's reciprocal. If you added a constant times a non-zero constant times a row to another row, you're going to subtract that same row times the same constant from the same row. If you swap two rows, you're going to swap those two rows again. If E is an n by n matrix, how might you obtain E, the inverse of E, from an identity matrix? Elementary matrix is n by n. You're going to obtain the inverse of E from I by doing the opposite, right? It's the same type of conversation we just had, or statement basically, where it's like, if E is a result of multiplying a row by I, you're going to multiply I by the negative number, negative constant. If you swap two rows, you're going to swap those. Swap those two rows again. Yeah. On I. And if you added a constant times a row to another row, you're going to subtract constant times a row to that row. I meant reciprocal for the first one. Okay, good. I think we got it right. If E results by interchanging rows I and J of the identity matrix, then interchange rows I and J. Yeah. Okay. What does it mean to state that a matrix has size mxn? It's got m rows and columns. Elementary matrix is a matrix that can be obtained from performing one elementary row operation on an identity matrix. Come on. Lag. Okay. If the elementary matrix E results by performing a certain row operation on the identity matrix I, if the elementary matrix E results by performing a certain row operation on the identity matrix I, how is the product EA related to matrix A, assuming that this product is defined? If the elementary matrix E results by performing a certain row operation on the identity matrix, how is the product EA related to the matrix A? EA is going to be like if you perform that same elementary row operation that you did on I except on A, if assuming that the product is defined. The matrix EA is the same as the matrix that would result from the operation performed on I was performed on A. Okay, yeah. So today I'm going to go do a review problem and then a problem from 1.7, and then we're going to continue doing more of these Anki flashcards that I had not done or forgot to do from the last two sections. So I'll be back in a little bit to recall what I did. All right, so actually I forgot to grade what I did yesterday, so I went ahead and did that, got it right. And then the review problem was from 1.4. It was basically to solve this system of two linear equations with two unknowns via matrix inversion. That took a bit to remember what to do, but eventually I figured out. I remembered that ax equals b, so that's what it means by inverse. And multiply both sides by the inverse of a on the right. So you get x equals the inverse of a times b. So first you got to find the inverse of a. There it is. And then you multiply that by b, and there's the solutions. Then 33 from 1.7 was basically verifying first that the product of two upper triangular matrices is upper triangular. So there you go. Not proving, but verifying. So there we go, showed it. And then also for 33, not quite done yet, but verify that the inverse of an invertible upper triangular is also upper triangular, so we're not quite done with that. So tomorrow we'll finish this problem, and then we'll continue with the Anki flashcards, because I didn't have time to get to the Anki flashcards themselves today. So that's it for today. Talk to you tomorrow. See you.